Had a chance to look through and try some of them or most of them. I'm not sure what I was hearing, whether I was hearing a good first step is to divide by 3 or a good first step is to multiply something. When you're faced with something different here, don't just think, well, it's different, I don't know how to do it. Think about how you can make sense of it with what you already know. The reason that this is in here, obviously, is because, well, not obviously, but this 3 confuses the issue a little bit here, multiplied by 3. If you can think, how could I write an equivalent equation without breaking any of the rules, that's what you should be thinking, not, wait a sec, what do I do when I see one like that, or what am I supposed to do? That 3, think about a simpler, you have multiplication and an exponent here. If you had 2 times 3 squared, think about whether you can multiply those and is it going to be equal, right? If you multiplied that 2 and that 3, is it going to be equal? Like, is that going to be, is 6 to the 2 equivalent to that? Is 6 to the 2 equivalent to 2 times 3 to the 2? Not, right? This is what you need to do first. So when you're working backwards, when you're solving equations, you work backwards, you got to deal with this 3. If you have 3 times something is equal to 1875, then divide both sides by 3 and you just have the something. If you divide both sides by 3, you just have 5 to the x minus 2, and you have whatever this is divided by 3, 625. So that's what makes that one different, and how it requires a bit of thinking at first. After that, same thing though, right? You can write them both as powers of 5. You might not instantly recognize 625 as a power of 5, but for this section it would help if you brushed up on your powers of certain numbers, certainly the smaller ones. Again, the concept is if you can write them as powers of the same base, if the bases are the same, then the exponents have to be the same. So then you can write x minus 2 as 4, so x is 6. You can go back and check it if you want, put it in the calculator and make sure it works. I'm going to assume that this one you're probably okay with. Write them both as powers of 3. This one maybe we have to remember, because this fractional, writing things like that as an exponent is sometimes tough. You learn this in grade 9, and it's actually pretty abstract to learn in grade 9. I think some people don't get it in grade 9, not because they don't try or anything like that. It's because it's a difficult concept in grade 9. It's pretty theoretical. Let's say you have... You want to be able to write these as powers of the same base here. 1/16th, what is that as a power? You might remember, that's fine. I mean, it's, remember that. Come on. There we go. 2 to the 4th, 16. 2 to the 3rd, the only way I can make sense to you of this is just to look at the pattern in the powers, right? 2 to the 2nd. 4, 2 to the 1st, 2. This one is the first one that confuses people in grade 8 or 9 when they're first learning it. 2 to the 0, what is that? You want to say 0, but it's actually 1. The pattern on this side is every time you drop the exponent by 1, you have 1 less 2 here, right? It's the same if you think of tens, right? 10 to the 4th, 10,000. 10 to the 3rd, 1,000. You're dividing by 10 each time. It's 1 lower power of 10. This is 1 lower power of 2. Every time you drop it down by 1 here. As soon as you get to 2 to the 0, you don't have any 2's left. You just have a 1. If I drop it even 1 more, you're kind of in debt a power of 2, right? A half. Not only do you not multiply by a 2, you're actually dividing by a 2. Okay? And then you keep going here. 1 over 4. You got to divide by 2 twice there. Here you don't multiply by 2 3 times, you divide by 2 3 times. If it's a negative power, it's not multiplying by that number 3 times, it's dividing by that number 3 times. So 2 to the negative 4 is the same as 1/16. That is a pretty tough thing in grade 9. Maybe you can make some sense of it now. It's just whatever the positive power is, it's the reciprocal of that. So if you want to know what 1/16 is, just think about what is 16. If 16 is 2 to the 4, this is 2 to the negative 4. to the x. And then this is 2 to the 3. So you're writing each of those things. 1/16, 2 to the negative 4. 8, 2 to the 3. And then we need the rest of it here, 5 minus x. And then you can follow it down, right? 2 to the negative 4. 2 to the negative 4x equals 2 to the 15 minus 3x. Common mistake here would be, what do you think a common mistake would be here to getting to that step? With dealing with that. The 3x, yeah, probably writing just that. If this was the other way around, it would be forgetting to multiply the second thing, right? If you continue that down, you can come up with an answer there. This last thing, hopefully you've done here. I would, as a kind of a summary, like you to make sure you know what that you could explain to somebody what an exponential equation was. That you could explain what related bases were, what we mean by that. Maybe I should give you a few more examples here, or not fully solved examples, but these were related bases. 1/16 and 8 are related bases because they can both be written as powers of 2 nicely. An equation like 2 to the x equals 11, these are not related bases because you can't write 2 and 11 as powers of the same number very easily. Certainly not with nice integers the way we're doing here. When it's set up above things that are integral powers, it means can you write it with integers? Can you write them as powers that match with integers, right? 2 and 11, there's no way you can say 11's not, you can't write that as 2 to the something where this is an integer. All right? We're going to do that later, unrelated bases. If you flip a few tutorials ahead or a few sections ahead, you'll notice that we're going to do unrelated bases. All right? And then the last thing here, if you could just explain to yourself, write a kind of a summary, it'll help you solidify it in your mind. What's the strategy for solving an equation that involves related bases? If you're saying, well, first you got to do this and then make these the same and then do that and look at the equation, look at the exponents and blah, 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 whatever you like. This last thing here, at the end of each of these tutorials, there's going to be a suggestion. I'm saying suggested practice because, who are we kidding here? You're grade 12s. Some of you are going to do work. Some of you are going to do absolutely nothing outside of this room. I will tell you who I would put my money on as to which type of person is going to be the ones that are doing well in the course. In the end, it's going to be the people that are doing stuff outside of class as well, even if they're only doing 10 minutes of stuff outside of class. This helps. But I'm still saying suggested. I'm not forcing anybody to do anything. It's grade 12. I'm not going to check homework and all that kind of stuff. It's up to you. You want to do well, you practice, right? You want to be a good hockey player, you practice. You want to just be a mediocre hockey player, you just go play your game once a week, right? It's the same as anything, okay? The practice for this is at the end of this booklet. So if you flip ahead here to the very end of that booklet, there is going to be often that suggested practice will be from the textbook. Sometimes it'll be from additional things. Sometimes it'll be right there at the end of the tutorials. It's just different depending on what I thought was best to set it up. You have to look for titles. I didn't put the numbers here. I didn't say that this is the practice from 2-1. But you got to look at the titles here. I'm looking for related bases, so it's that. Even if you do some of these now and some of them when you get home. I know that sometimes, hey, I don't want to have any homework, I'm going to get it all done here. That might be a good strategy, but as you get to higher levels here, and certainly now when you get to university, the point is not to, the reason you have homework is to solidify it in your brain. If you were to just do even a couple of these sometime between now and next class, your brain has seen it a second time and thought about it a second time. The fact that you've just seen it a second time is going to help you learn it that much better. It's great if you do all of these now, and do nothing before next class, but then your brain hasn't seen it a second time. If you want to learn something, you see it repeatedly a little bit at a time. If you learn it a whole big chunk all at once and then you go a long time without seeing it, you don't learn it as well. If you study for 2 days solid for a test, take the test, and then you wait a year, you're not going to know it in a year. If you do a little bit, 10 minutes a day for the whole year, even though it adds up to the same time, you're going to know it far better seeing it 10 minutes a day all year, right? That's what I'm saying. So 10 minutes of something, even doing a couple of the questions between now and next class would be, I know we have it after lunch, which makes it different, but when you come back, try a couple questions, but then we'll leave some of that for you to do before next time when we're going to look at the second tutorial, okay?